This no barber shops being open is kind of killing me. I need to get to the barber here pretty soon and get this hair trimmed up. Little weekly schedule here. Monday, today, we're going over section 7.5. Video assignment will be due Tuesday, 11:59, typical format. Conference from 12:30 to 1. If you need any help, Tuesday, April 14th, 7 to 7:1 to 7:5, review video notes. We'll be reviewing some concepts from 7:1 to 7:5. Okay, there will be an assignment due Wednesday, 11:59. That'll be a review assignment. Canvas conference from 8 to 8:30 that day, probably if you have questions over the previous day. Wednesday, April 15th, there will be no video notes. Study for the 7:1, 7:5 test. Okay, Canvas conference from 12:30 to 1. This is when you should definitely make sure you're getting into these conferences, asking questions, going over your stuff, reviewing. Thursday will be the test. Okay, modifying a couple things here. It'll be posted at 7:30 a.m. It must be submitted by 9 a.m. 8 to 9 is the time allotted for your math Canvas conference, so we will use that for your test. I will post it at 7:30. If you have a situation, you need to make sure you notify me ahead of time. I should not be getting any emails at 9 o'clock explaining why you cannot take it till later. Okay, if there are some circumstances that are legitimate, not that you like to sleep in, email me, let me know so I know ahead of time. Friday, April 3rd, off. No video notes, no assignment. We'll pick back up on Monday. But big thing here is we're having a test on Thursday. Only one new section, which is 7.5 for that. All right, on that review assignment over 7.4, kind of put everything together. Number 10, actually, yep, number 10. That was a little bit difficult. If you read it, it asks, compute the speed and bearing the pilot will need in order to maintain the desired course and maintain an average of 600 miles per hour. So here's what I need you to think about. The first one, and I'm just going to set this up because this really isn't due till tonight, and then you can see whether you got it right. And actually here, let me give you the answer. If you got the speed to be, this is what it actually is going, and then with the wind, it'll end up averaging 600 miles per hour. It should be 637.89 miles per hour. And the bearing is south 80.45 degrees west. That should be your final two answers. If you got those, boom, congrats. Move on. Don't worry about what I'm saying here, because there's a couple different ways to do this. All right, if you didn't get it, I'm going to at least try and set this up. All right, the first one here, the plane is going on a bearing of south 75 degrees west. That will be this right here. Okay, south 75 degrees west. That means this right here will be 75 degrees. The 70 miles per hour wind, I don't know if anybody noticed, that's probably like a hurricane force wind. But hey, we're going to fly anyway. 70 mile per hour wind is blowing from the northwest, bearing south 45 degrees east. That will be right here. Okay, that will be right there. Think about that. This angle right here is 45 degrees. Okay. Now, I want you to think direction here. So for the first one, south 75 degrees west. What is that direction? The direction is this angle here. Well, we need to find this small angle here. Well, if that's 75 off the south line, that's got to be 15 degrees. It's going to be 195 degrees. Okay. The direction for the other vector, okay, which is south 45 degrees east. Okay, That's all the way around here. So that's 270 plus 45. 270 plus 45 is 315. Okay, now let's take a look at what's going on. If the pilot flies on its normal course, okay, if it flies at south 75 degrees west, the wind will push it, okay, along this path, and it will end up right here. Well, what path will it have to take to end up right here? Okay, that's what we got to do. Well, if you think about this, if I just take this vector, and remember what happens if you subtract a vector. Okay, I'm going to flip it, and I'm going to flip it again. If you subtract a vector, you go the opposite direction. So in reality, here's what you have to do. This is where the plane should head, and then this, I'm going to call this U, and this is V. U plus V, U plus V, hold on. Why am I losing my vector? U plus V would put me here, okay, which is not, that is off course. If I want to end up at that spot here, I have to actually do U minus V. Now you can also do add the opposite, but this would work here. So you gotta, we want to do U minus V. Well, U will be the first vector here, the plane speed. So remember what we do, we got to convert it to IJ form. So it's going to be 600 degrees times cosine of 195 degrees I plus sine 195 degrees J. That's U. V is going to be 70 miles per hour times cosine of 315 I plus sine 315J. And now U plus V would end up over here. And to figure out how to get to this point right here, this is where I want to end up, I can do U minus V. So I'm going to actually aim along this vector. The wind, okay, the wind is actually still going in this direction. It's going to push the plane to that spot right there. So we have to account for the wind. See if you can do this, and you end up with 637.89 miles per hour in south 85.45 degrees west bearing. Now remember, that's going to be your bearing, not your direction. All right, see what you get for that. And then we'll go over this in the Canvas conference as well, probably. All right, we are going to move into section 7.5. We're going to do 7.5, and then just because of how this is working out, it's going to be easiest if we test, for me and for you, if we test over 7.1 to 7.5. Now, we didn't do 7.3, which is fine. And then there are two other sections. We're just going to kind of do those independently in chapter 7. All right, 7.5, we're going to talk about dot product. It's something totally new. We did vectors in 7.4. And we're going to move into what's called the dot product. All right, there are guided notes. I forgot to mention that earlier. If you go to your modules, okay, where this is posted, you'll have your guided notes here. You'll have your lesson video. Go ahead and print those out. If you have a printer, you don't have to. Okay, by no means do you have to do that, but I think it's helpful if you can. You might need to go to like one of your own kind of desktop, or if you have your own laptop to print off of. Okay, here's what the definition of a dot product is. You have two vectors, V. And remember, this is a position vector, V1 comma V2. It means its original point is 0, 0, your initial point. And W is W1 comma W2. The dot product of V and W is denoted V dot W. It is, you just multiply V1 times W1, kind of what you think of as the X components, multiply those together, plus V2 times W2. Your answer is a constant. It is not a vector. Okay, the dot product is not a vector. Okay, that's going to be key. All right, just making sure we understand the procedure. Find the dot product of 2 comma negative 3 and 3 comma 4. All right, well, the dot product is you take 2 times 3 plus, okay, this 2 times this 3 plus negative 3 times 4, negative 3 times 4, and then that's going to equal, what do we get there? 6 plus negative 12, which is 6. That's your dot product. Dot product is 6. All right, second one here. Now that's a position vector. This is IJ form. You could probably go straight from here if you wanted to. You could also write that, remember, that is the same as the position vector, negative 3, 5, and 2, 3. Okay, for those. And so your dot product is negative 3 times 2 plus 5 times 3, and I get negative 6 plus 15, and I get 9. So that's my dot product. Well, what is all this for? Okay, why bother? Well, it's going to come up here. We're going to talk about the angle between two vectors, and then we are going to discuss orthogonal vectors. Now, the section 7.5 goes a lot further, and then we ended up getting, and this is a big physics thing, the definition of work and dot product comes into that. We are not going to deal with that. It does come up, and like I said, other subjects, we could go into it, but we're not. And we're just going to talk about the angle between two vectors and what's called orthogonal vectors. Okay, here's where the dot product also comes into play. All right, the dot product and the angle between two vectors. Well, if you have, this is vector one, your initial vector has a terminal point Q. This vector has a terminal point P. The angle between them is right there. Now, any two vectors, we're going to let theta be the angle between 0 and 180. We're not going to talk about the angle that is bigger than 180, just the angle that is between 0 and pi or 0 and 180. Cannot have a zero vector. Okay, then here's what happens. The dot product is equivalent to the magnitude of V times the magnitude of W times the cosine of theta. Rearranging this by isolating cosine of theta, that is the same thing as the dot product. Okay, all you have to do is divide by the magnitude of V and the magnitude of W. So to find the angle, remember you're going to take the inverse cosine of the dot product times the divided by the magnitudes. All right, the derivation of that's in your book. It's pretty extensive, pretty complicated. I use the law of cosines if I remember right. Hopefully you'll accept that to be true. But there's your law, or excuse me, there's how we find the angle between two vectors. That's what we're basically going to use this formula for. Okay, let V, vector V, be the position vector, 2, 3, and W be negative 3, 4. All right, I just have them drawn there. I think they're on your guide notes. I can't remember. But we are looking for the angle between them. And this is an accurate drawing. There's the vector 2, 3. There's the vector negative 3, 4. This angle right there. Give it an estimate. See how close you are. All right, so cosine of theta is equal to the dot product divided by product of the magnitudes. So we want to find the angle between those. So cosine of theta. All right, the dot product. Okay, 2, this 2 times that negative 3 plus 3 times 4. All right, magnitude of V. Magnitude of V, remember what that is. That's the length of it. That's going to be 2 squared plus 3 squared. And W, the magnitude of W, is going to be negative 3 squared times 4 squared plus. And let me write that a little bit nicer. Negative 3 quantity squared plus 4 squared. All right, let's see where we're at. 2 times negative 3 is negative 6 plus 12. 2 squared is 4. 3 squared is 9. I get the square root of 13. Negative 3 squared is 9. 4 squared is 16. That adds up to 25. So now I'm at the cosine of theta equals negative 6 plus 12, which is 6. All right, square root of 25. Not that we have to do this, but it's 5. 5 radical 13. So that means that theta is the inverse cosine of 6 divided by 5 square root of 13. So let's see what we get there. So inverse cosine 6 divided by, now I'm going to put this in parentheses. Depending on what model calculator you have, you might not have to. All right, I get 70. I can't remember what I rounded. Let's go to the nearest tenth. It's fine. Oops. 70.6 degrees. That seems logical as you take a look at that. It's definitely not an obtuse angle, so 70.6 degrees is correct. So that's the angle between V and W. All right, why don't you pause this, see what you get for the angle between V and W for those two. Okay, I'm going to pause it as well. Okay, we're back. All right, let's see what you got. All right, so for vector V, you can think of it as a position vector, negative 4, 8. W is 5i minus j, which would be 5, negative 1. Now, I just did a quick sketch over here just to kind of give myself a visual. Not that you have to, but sometimes it helps. We are looking for always looking for the angle that is the between 0 and 180. It'll be the smaller of the two angles. So this will be the final angle that'll be our answer. All right, when we take the dot product, I take negative 4 times 5 plus 8 times negative 1. The magnitude of V, the magnitude of W. I end up with negative 20 minus 8, square root of 80 times square root of 26. Well, those don't simplify into anything, no whole numbers. Don't need to reduce it. Don't worry about doing that. Just leave them as they are. So we get square root negative 28 times those two. Take the inverse cosine. Watch how you enter it into your calculator. Here I put the whole denominator in parentheses, and I got 127.9 degrees, which makes sense. Looks definitely more than 90 degrees. And it has to be less than 180. All right, so that's how we do the angle between two vectors, and this is how the dot product is used. Okay, we are going to talk about two things, parallel vectors and orthogonal vectors. They're very similar. Parallel vectors, two vectors V and W are parallel if there is a non-zero scalar C such that V equals C times V. The angle between parallel vectors is either 0 degrees or 180. Okay. And now a couple facts will come up if we do have parallel vectors. So if V and W are parallel, if and only if the dot product is equal to plus or minus the two magnitudes multiplied together, or you end up getting a ratio of V1 over W1 equals V2 over W2. Okay, that'll work as well. All right, now let's just take a look. It says determine whether vectors V, 2i minus 3j, and W are parallel. There are different ways that you can go about this. Let me write V as 2, -3, and let me write W as the position vector -4, 6. Let me make sure that a comma. All right, well, one thing here, if we go back to this, is that if one is a scalar multiple of the other, so you might look at them and you might know, boom, right now, whether they are or whether they're not. But if you think about it, what can I multiply W by to get, or V by to get W? Well, it looks like W is equal to -2 times V. Let me make that a V. Okay, because -2 times 2 -3 is going to give me -4 6. All right, right there, that lets me know they're parallel. All right, so if you think about that as the position vector, 2, -3 would be here, and now -4, 6 will be basically right there, going straight the opposite direction there. So they're going to be parallel vectors. Now, if you don't recognize it right away and you go to do your work and you say cosine of theta equals the dot product over the magnitude of V times the magnitude of W, and you say, all right, let's take a look at what happens. So you would take 2 times -4 plus -3 times 6. And now the magnitude of V is going to be the square root of 2 squared plus -3 squared times -3, square root of, hold on here, the magnitude of W, which will be -4 squared plus 6 squared. All right, what do we get here? 2 times -4 is -8 plus -3 times 6, which is -18. 2 squared is 4, so that's square root of 13. -4 squared is 16 plus 36, square root of 52. So what do I get here? I get -8 plus -18 is -26. Square root of 13 times square root of 52. Hold on. Now, if you would do this, so inverse cosine, -26 divided by square root 13 times square root of 52, and we get 180 degrees. Okay, it said two vectors are parallel. The angle between that is either 0 or 180 degrees. All right, now this says that the dot product will be equal to plus or minus the magnitudes. Okay, now let me just show you how that really worked out here. The dot product was -27. Excuse me, -26. The magnitudes, the magnitude of V times the magnitude of W was the square root of 13 times the square root of 52. Well, I don't know if you recognize it, but square root of 52 is 2 square root of 13. And what do we get when I multiply square root of 13 times 2 square root of 13? Well, square root of 13 times square root of 13 is 13. 13 times 2 is 26. So I ended up getting the exact same thing in my numerator, except for a negative. They just differed by a negative. So I had -26 in the top, positive 26 in the denominator, 180 degrees. Therefore, they're parallel. Okay, so that's how we determine whether vectors are parallel. If you recognize right away one's a scalar multiple of the other, you kind of save yourself some steps. Now, the last thing is what's called orthogonal. Okay, two vectors are orthogonal. An orthogonal is only a fancy name for perpendicular. Okay, we use that with vectors. Two vectors are orthogonal if and only if their dot product equals 0. Okay, because if their dot product equals 0, okay, you got cosine of theta equals the dot product divided by the products of their magnitudes. Well, if the dot product is 0, that whole thing is 0. And if you take the inverse cosine of 0, you get 90 degrees. Okay, so all I have to do is find the dot product. Well, it says find a scalar c, so the vector is v, which is 3i plus 2j. I'll write that as a position vector. And w, which is 4i plus cj. So I just make that a 4, and then I don't know what that value is, so I make it a c. So I have to have that equal to 0. So take the dot product, which is 3 times 4, plus 2 times c has to equal 0. 12 plus 2c equals 0. And just solve this like in typical linear equation. Subtract 12. 2c equals negative 12 divided by 2. C equals negative 6. So that's how we figure out orthogonal. Well, in this case, we find the missing value to make them orthogonal. Okay, their dot product will have to equal 0. Okay, that's what we're going to do for section 7.5. All right, here's the homework assignment for that. That's due Tuesday. Okay, the 14th by the midnight bell. And then after that, we're going to start reviewing. You will have a review assignment on Tuesday, nothing on Wednesday, but the study, and then test on Thursday for that. Start making plans, have it turned in by 9, and I need to hear immediately if there's an issue, or as soon as if something comes up, I need to do that. All right, have a great day. We will talk to you either later today, maybe tomorrow, or definitely for sure tomorrow.